Okay, cool, great. Well, hi everyone. Thank you so much for joining us. I'm glad I could have your time. Today I will be presenting my tutorial project for the second term of 2020 at NCA. So the basic aim of the project was to build and program an Arduino-controlled, battery-powered, two-wheel drive, autonomous, or at least semi-autonomous robot that was capable of both tracking a line and avoiding obstacles. So the big question, is this project complete? Well, mostly. So I did manage to get it to track a line, and I did manage to get it to avoid obstacles, but I really struggled to get it to do both at the same time. And I'll be able to give you a bit more evidence on that later on. But it is built and assembled, and for the most part, it is able to move. In fact, I have it right here. I'm not sure if you can see. And then I've got two pictures of the basic setup. I'll talk you through that in a bit more detail in a few minutes' time. So, brief background to this whole thing is that we were sort of caught up in the national COVID-19 and international COVID-19 affair. And so I think we all made the decision to stick with just focusing on the tutorial project and getting through that content rather than trying to do both this and a design project. So it was nice to have the extra time to spend on this and to be able to channel a bit more of that creativity into using this as the main project for the term. In terms of what else is out there, well, it's so great with the Arduino technology that it's open source. So there was a bunch of online supports where I could find very similar videos on YouTube, and other students and fellow tinkerers had sort of done very similar things. Yeah, so it was lovely to be able to tap into that a bit. Yeah. In essence, the main similarities and differences that my project has with what you'd see online. In terms of similarities, it uses Arduino technology, and it uses a lot of the same sort of sensors and controllers that you would see if you just typed in, Arduino line following, obstacle avoiding robot online. Same basic layouts in terms of the physical component setup. Some sort of distinctions, or what sets mine sort of apart from the others. I did try to use a servo motor, which you can see a couple of examples of online. The thing I think that really makes mine stand out is that, ooh, it's falling off, that's not good, is the use of a relay. How do I best show this? Right there, yeah. It's a single 24V DC relay that I just popped on with a little breadboard. And the key function of that is just so I didn't have to have two switches, because I did separate my DC power supply. So I've got one power supply for the Arduino and then one for the L298 and motor driver. So it was, I'll talk about that in a bit more detail as to why I made the decision to separate the two power sources, but yeah, it comes into play there. And then using single 9V battery cells rather than whole battery pack, just to make the physical layout a bit more streamlined. Okay, right, so these are some of the key YouTubers I really wanted to highlight. I followed their videos, mainly DIY Builder had some great ones, both for line following and obstacle avoidance. And it was lovely with this being such an expansive open source community that, you could tap into what other people had done, and sort of you could look at their coding and their programming and the way they'd set it up. A lot of these videos followed the same sort of format, that they'd have a demonstration in the beginning or the end. So I could sort of see if it was relevant to what I wanted to do, and I could build on that. Oh, I also want to highlight Eli, the computer guy. He had some very fun videos. So yeah, it was interesting to sort of switch from learning from a textbook sort of curriculum to more online, trying to disseminate information for myself. It was really pretty interesting. Then also the Arduino Project Hub official page was very, very useful. I really appreciated that. A lot of the projects uploaded would also follow a similar format where they'd outline sort of what they used, and then they'd give their source code and they'd give a schematic. And so I could sort of see what would be relevant for the applications I wanted to use. In terms of design, I opted to use an existing Perspex chassis for the car, rather than redesigning my own one. So the only real modifications that I made there was drilling a few extra holes. But what I did do in terms of design work is a sort of like a holder for the ultrasonic transducer. I don't want to call it a bracket because it's not really, but it was specifically so that I could mount it onto a servo, so I could get it to look left and right, which was a function that I later on abandoned. But yeah, I've got some sketches for that, some 2D hand-drawn as well as SolidWorks, although I cannot take credit for the hand-drawn ones. That was done by a fellow tinkerer named Jordash. And so you can sort of see a couple of the iterations that this thing went through. It was lovely to play around on SolidWorks again. You can see sort of version 1, very, very basic, and then sort of as I realized I wanted to incorporate the servo motor, it got gradually a bit more involved. So yeah. Bill of materials, I did end up spending some money on this. It doesn't look like a lot now, but I learned very quickly that batteries were the biggest cost drivers. Yeah, so that's definitely something to take into consideration next time. This motor driver at the back, it's chowed up a lot of my power, and I had to learn the hard way that I needed to keep replacing my batteries, and eventually opted for rechargeable batteries, which make for quite an expensive once-off purchase, but I feel like it's still a worthwhile investment for future projects. Oof, I've got a very simplified sort of componentry where I've split things up into controllers, sensors, general electronics, and then mechanical components for the car. The two main drivers, as you can see, are the Arduino Uno microcontroller board and the L298N motor driver. The main sensors that we would use, or that I did use, was the ultrasonic transducer for sensing obstacles, and then the IR sensors for line tracking. I've got a very simplified wiring diagram as well. I used the Tinkercad circuit assemblies in order to create this. I found it extremely useful. It really helped me to get a nice, sort of neat and coherent layout. So I used it for both the physical component layout as well as the electrical wiring connections. It was much more sort of, I could customize it a lot more easily than I could on like the fritzing. So I did look into fritzing initially, but this just seemed better for the purposes I wanted to use it. Unfortunately, they didn't have all of the components. So like the motor driver, as you can see, isn't really there. They had a single H-bridge motor driver, but I just try to simulate it as best as I can. But I do hope that it demonstrates sort of how everything is connected. Okay, I've got a very short algorithm flowchart. This is specifically for the obstacle avoiding program. That in essence, what I wanted this bot to be able to do was ping for a distance using that ultrasonic sensor and check if the distance was less than or equal to 15 centimeters, that it would enable this obstacle avoidance routine, or the OR as I call it, where it essentially stops, moves around the obstacle and past it, and then gets back onto the line. And then from there onwards, it then continues with the line following routine. If distance is greater than 15, then it can just keep following the line, carry on about its business. And I think that worked pretty well. Yeah. Key problems that I encountered was, as previously mentioned, that the motor driver was a rapid consumer of my power, the bugger. So I just, yeah, it would, as soon as the voltage dropped below like 7 volts or so, it just was almost impossible to write a functional piece of code to it. So my fellow tinker and I decided to separate the power support supplies totally with the 2 different batteries. We've seen a couple of examples of this being done online, and it did seem to prove successful. We had an insufficient sort of in-house supply of male to female connectors. So we just sort of modified them, which was a lot of fun because it gave me a lot of practice in soldering and stripping and reconnecting the wires. So that was really cool. Another key issue would be that initially my IR sensors were quite far apart. So it meant that my line following in the early stages lacked a lot of sensitivity, but we managed to remedy that by just repositioning them a bit closer together. Yeah. Troubleshooting. Oh. This was really quite an exercise in going step by step through what went wrong, because a lot went wrong, but it was challenging and interesting, very, very interesting. So you always start with the batteries and you always start with the hardware, and then you look at the coding and then you look at the wiring. And here, having that wiring diagram was absolutely invaluable just to sort of keep my head together and figure out what connections went where. And I really, really wish that I'd made one earlier. Oh, sure. And it's There were a couple of problems that I still don't quite know why it's not doing what I wanted it to do, but for the most part, I think it is working, but this was a huge frustration. But still, I think a very, very valuable learning curve, although quite steep. Proposed improvements for the future would be that I really, really think it could do a lot better. It could perform much, much more ideally if we had a stronger and steadier source of DC power to the motor driver. Yeah. Then obviously an increased number of sensors, at least the IR sensors, so that it could take different sort of gradients of turns, because we certainly found that I was writing a particular speed to the motors that was fine on certain turns, but then on the sharper ones, I would have wanted to be able to adjust that a bit better. So there were multiple times my bot almost went off the table entirely. So I feel like that could have been avoided with more sensors. And then if I had more time, I would have liked to have to have modified my chassis, just so that it could have been a bit more coherent, a bit more logical in terms of the layout. Major technical difficulties, I think, would include that the motor driver drained my batteries. I'll keep coming back to that. I had a lot of trouble initially with writing to this little servo motor. It seemed to interfere with the motor driver until I eventually realized, with the help of another student, Nicholas, that it was disabling the analog writing to particular pulse width modulation pins. So that was interesting to learn. And I was unfortunately unable to get my bot to perform both the line following and the obstacle avoidance on that curved track. However, some major technical breakthroughs that I think are worth noting would be that I did get it to manage to avoid consecutive obstacles on a single track. And I did manage to eventually find a way of bypassing that disabling function of the servo motor so that I could use it in conjunction with the motor driver. I also think that it is worth noting that I did not use the Arduino sensor shield that was provided, purely because I was able to cannibalize a bunch of the connections. So I didn't need to take up too many pins. Yeah. Division of labor. I need to give a shout out to my fellow tinkerer, Jordosh Leroux, who definitely was invaluable on this project. It was so, so lovely to be able to simulate the classroom environment on a micro scale in the household and work on a project together with him. And he is brilliant with the hardware understanding, so he helped me to sort of bridge the gap in my knowledge there, and I focused a bit more on the programming aspect of things. But yeah, I learned a lot, and I couldn't have done it without him. Other honorable mentions would be Alistair, another former student who shared his initial source code for line following with me, and who I had multiple Zoom meetings with, and distress calls were sent in his direction. And then Nicholas Collins as well was hugely invaluable in just helping me understand where I'd gone wrong with my coding and why my motor driver was acting funny. Yeah, absolutely. And then of course the whole NCA team for making sure we had coffee the whole time. Yeah. And for supporting all of us through this process, absolutely. And then my dad, for not only providing financial support, but also like emotional support with this whole thing. Yeah. Central ethical impacts. I don't feel like I can speak too much on this particular subject. I think this tutorial project was a great sort of introduction for me into the world of programming of microcontrollers and sensors, and I can definitely see application for that in the future, given this sort of increasing trend towards remote access and remote control. So I'm very much looking forward to learning more about this from the comfort of my own home. All right, then in terms of technical evidence, I've got some extracts from my activity logs in which I noted that I spent about an average of 13 hours a week on this project. I've got a few extracts from the reflective comments that I did. I was actually really grateful to the whole PPD experience this term. I think we had some very interesting and thought-provoking reading material that helped me sort of keep a good work ethic. It was challenging trying to incorporate studies into a domestic environment, and yeah, it definitely helped being able to just switch brain to something else for sometimes. Yeah. And then to be able to apply that back to my project. And then I've got some extracts from the code that I used, or the code that I wrote. So on the left, we've got an extract from my obstacle avoiding code, just like the sub functions for turning left and turning right. And then you can sort of see how that would then be used later on towards the right in the line following program itself. It was essentially a bunch of if-else statements. Yeah, try to keep it as straightforward and condensed as possible. So an overall assessment of, or self-assessment of my mark, I think I did all right. I tried to stay up to date in terms of the paperwork and the documentation. I did struggle a bit with time management, just having competing commitments with domestic life and then studies. But yeah, just tried to do a little bit every day, absolutely. The programming, I've rated myself relatively low. I feel like I'm slow to learn, but it is starting to make more sense, absolutely, and I'm keen to learn more. And then problem solving, I feel like I could have done better. I leaned a lot on the help of my fellow tinkerers. Yeah, but I'll get there. I'll definitely get there. So personal progression, key things I'd like to highlight is, well, some skills that I feel like I learned throughout this whole process. In the beginning, I had no idea of how to do any type of coding to the Arduinos. So I just kept at it, and I feel like I've definitely got a bit of a better understanding of how to navigate that. I could not work with soldering iron in the beginning of this term. Now I can kind of do it a bit better, a bit neater. And then a lack of exposure to the whole troubleshooting process. Plenty of practice, and I feel like I sort of understand a bit better how to introduce one variable at a time and work from there. So some positive habits that I managed to sustain would be a work ethic and an attention to detail, and a sustained enthusiasm for what I was doing, even if I didn't understand it most of the time. Some negative habits could be a lack of initiative. I did ask for help a lot. I practiced what's the word? Productive, thank you. Productive procrastination. I would clean my entire workstation like an hour before starting on any work. So I'm not sure if that's a good or a bad thing, so I thought to put it in there. And I did spend a bit long on neatening up my wiring diagram instead of actually getting to the programming. Insights gained for future projects would definitely be to make the wiring diagram at least and the flowchart algorithm at least upfront, so I've got a better idea of how to tackle the work ahead of me, and to use rechargeable batteries. Yeah, absolutely. All right, so thank you for your time. I've got some videos that I'd be happy to share with you guys to show like it actually doing the thing that I wanted to do. Yeah, but that's about everything that I have to say. Any questions?
Y/X?
Oh, that's my dad. So I think he talked about it briefly last term, that he's got this rule that if you know what you're doing and you've done it before, things take quicker. But if you don't, then they take longer. And this is sort of his formula of how he works out exactly how long things are going to take and how to make more accurate projections of your time. Yeah, but anyway, thank you.